Hello and welcome to today's class. In today's class, I'm going to discuss a very important concept that we are going to build on as we start solving quadratic equations, using completing square method, and that is the concept of quadratic identities. All right. So one thing I want to say before I introduce what a quadratic identity is, before I talk about what a quadratic identity is that uh, quadratic equations or expressions are usually not all though are usually a product of are usually a product of two square roots sometimes. All right, so what you're getting here is that quadratic equations sometimes usually a product of two square roots. All right, so sometimes quadratic equations and expressions are usually a product of two square roots, and therefore it means that if you have two if you have two linear expressions, you can basically multiply them together with each other to get a quadratic expression, which is basically a square of its product. What I mean in essence is, let us look at, for example, a casing scenario here. All right, so let's have a scenario where we have in a plus b, all right, which is a linear expression. All right, then we decide to multiply a plus b by itself. All right, so we have a situation where we're multiplying a plus b by itself. All right, so that is a plus b times a plus b. What do we get? All right, so basically this is a problem that requires expansion. So we're going to break one and maintain one bracket. Okay, so I'm going to break the one on the left and maintain the one on the right. So it's going to be a into b plus b into a plus b. And I want you to note what we're getting after we've expanded this particular expression. What we get then is a times a giving us a squared, and a times b giving us ab, plus b times a giving us ab, plus b times b giving us b squared. So note, this is not the final answer, as we can actually simplify what we have in the middle. That is ab plus ab. So when we add those two, we get a squared plus 2ab plus b squared. All right, so we get a squared plus 2ab plus b squared. Now I want you to think for a moment. How did we get a squared plus 2ab plus b squared? We got it by multiplying these two linear expressions by each other. All right, so this here is what we call a perfect square of a of a quadratic expression. All right, so this here then becomes what we call a perfect square. Right, this becomes a perfect square. And in essence, what we mean is that when you take a plus b and you square it, you're always going to get a squared plus 2ab plus b squared. Now, a case in point. Let us kind of prove this. All right, let us prove this particular quadratic identity, because this is a quadratic identity, by handling a real case scenario, or that involves a quadratic identity in the first example. All right, so this here is an example that actually requires us to use our knowledge on quadratic identity to solve a problem. All right, so we know for fact that this here is a square. All right, so basically we are supposed to find the square of this linear expression, that is x plus 5. All right, and we know that when you take a linear expression and multiply by itself, you're going to get what? A quadratic identity, which we already said, let me not really jump ahead of myself, which I almost gave a clue of how basically get what to basically expect from this particular problem. Sorry, let us just kind of refresh our memory on the previous work that we did in the introductory part of this video, and I took a plus b and I was supposed to square it. I want you to notice what happened with our answer. Our answer was a squared, all right? Note that we got a squared. And then we got what? Plus b squared plus the product of a and b times 2 plus the product of a and b times 2. So this here is a general formula for all quadratic identities that actually involves summation of a linear expression. So when you look at this example we are having here, that is x plus 5 squared, we can almost tell what the answer will be even without going through the whole process of expansion, just based off this idea that we have up here, which we derived when we expanded a plus b times a plus b in the previous example. So basically, when we look at here, we can almost tell what the answer. When you look at here, we can almost tell what the answer will be. We know that the answer is going to surely be x squared. All right, and then plus 5 times 5 times 5, that is 5 squared, 25, plus x times 5 giving us what? 5x times 2. Remember, it is 2ab, so it's x times 5 times 2 giving us basically what? 10ab. Now note, we have found this answer without really expanding. So by just looking at this particular problem here, which is a problem that requires knowledge of quadratic identity, we can tell what the expanded version of this problem will be. And now let us try and expand it and see if the answer we'll get actually is what we have here. So when you expand it, it's going to be x into x plus 5 into x plus 5, all right? And so that's going to be x times x giving us x squared, and x times what? 5 giving us 5x plus 5x, 5 times x giving us 5x there, times 5 times 5 giving us 25. All right, so note that for us to find the answer, we have to add these two here because they're they're like terms. So that's going to be 10x, that is x squared plus 10x plus 25, which is basically what we had here. Okay, so I am proving that by just looking at this problem here, because it's a quadratic identity, we can almost tell the answer. All right, and the way we are able to tell the answer is because we have a general formula that whenever you have a plus b squared, we always expect that you're going to get the square of a plus a times b times 2, that is 2ab, all right, plus b squared. All right, so this is a general formula of a quadratic identity, which we call the square of sums. Okay, we call it the square of sums. We call this the square of sums. So whenever you have a quadratic identity problem that requires that involves adding of two variables, that is two linear variables, and you're supposed to find their square, this is the general formula that you use in that particular case. So this is one thing you should note. Let me introduce you to another quadratic identity. So this is our first quadratic identity. Our second quadratic identity is what we call the square of differences. And let me demonstrate it. All right, so we are looking at our second quadratic identity, that is the square of differences. So earlier on, we looked at the square of sums. Basically, it was a plus b squared. Now, what if you have a situation where you have a minus b, and now you're supposed to square it? Now, this particular case is what we call the square of difference. And this identity basically states that whenever you have a times b, a minus b squared, the answer, the product of this particular identity will give you a squared. So that will be this a squared. Then we'll have a times negative b. That will be negative ab times 2. All right, so that will be negative 2ab. All right. Then negative b squared will be positive b squared. So this is what we call the square of differences. So if you expand a minus b squared, you'd actually find that your answer is actually equal to this. It's a general formula, and that is why we're calling it a quadratic identity. All right. So why don't we look at an example that actually requires us to do so? So example 3 here. So for example 3, we are having x minus 5 squared. And so looking at this second quadratic identity, that is the square of differences, we're having x minus 5, and we're supposed to square it. All right. Of course, we expect that the answer will be a quadratic expression. All right. And so when you have this particular scenario, it then becomes easy to tell what the answer will be just by looking at this general formula of square of differences. So we expect that this here will basically be the square of x, that is going to be x squared, times the product of these two, that is x times negative 5, which will be negative 5x times 2. So negative 5x times 2, negative 5x times 2 will give us negative 10 x. All right, then we'll have negative 5 squared, and that will give us positive 25. So by just looking at this problem without going through the process of expansion, we are already able to tell what the answer will be. And how are we able to do that? By following the second quadratic identity, that is the square of differences. So why don't I expand it so that you are able to see what I actually mean? We already know what the answer will look like, so I'm just going to expand it for you so that you know actually what we are talking about. So x minus 5 times x minus 5, which is what we have here, will basically be x into x minus 5 minus 5 into x minus 5. All right. So x times x will give us x squared, and then x times negative 5 will give us negative 5x, and then negative 5 times x will give us negative 5x, and negative 5 times negative 5 will give us 25. All right. Now note, these two are like terms, so we can simplify that. So basically, when you simplify that, it will be negative 5x plus minus negative 5x, which is actually negative 10x plus 25. So you are able to see that our answer here is the same as what we have up here. All right. So both of them are x squared minus 10x plus 25. And so that is a second quadratic identity that I wanted to introduce you to. So finally, as we conclude this class, why don't we look at the third quadratic identity? So the third quadratic identity is what we call the difference of squares. Now, assuming it's a rule, by the way, assuming you have a situation where you have a plus b, and you're multiplying it now not by a plus b again, you're multiplying it by a minus b. So you're having a plus b, and you're multiplying it by a minus b. How do you handle it? What do you expect to be the answer? So this particular formula requires that whenever you have a plus b times a minus b, your answer will always be a squared minus b squared. All right. Why don't we just kind of look at an example and see how that actually happens? All right. So looking at our last example, we were trying to discuss the difference of two squares as the third quadratic identity, we are having another scenario where we have 2x plus 3 multiplied by 2x minus 3. So the only difference here are the signs. So in this particular case, we are adding, and in this particular case, we are subtracting, but the terms are all the same. All right. So that is one thing I want you to note. So based on the rule we have here, that a plus b, when you multiply it by a minus b, we always expect the answer will be what? A squared minus b squared. We can almost tell what the answer will be even without expanding and going through the whole process. So we know that the answer will be the square of 2x, which will be 4x squared minus, all right, the square of b, which in this particular case happens to be 3, minus 9. And so this is what we expect to be the final answer. Why don't we do it and see it for ourselves? All right, because remember, this answer I've derived based on the rule, the third rule of quadratic identity, and that is that whenever you have a plus b multiplied by a minus b, you expect that the answer will be a squared minus b squared. All right, so in this particular case, I'll have 2x into 2x minus 3, plus 3 into 2x minus 3. So I have broken the equation, the terms in the left hand side, and I've maintained the bracket on the right. So basically it is 2x multiplying the bracket on the right, that is 2x minus 3, plus 3, all right, multiplying 2x minus 3. And so what happens when we deal with this? That will be 2x times 2x, giving us 4x squared, all right? Then 2x times 3, all right? 2x times 3 will give us 6x, all right? Then in here we have 3 times 2x. So that will be actually equal to 6x. And then 3 times negative 3, and that will be negative 9, all right? That will be negative 9. So note that when you simplify whatever we have in the middle here, that is negative 6x plus 6x, we're going to have that being equal to 0, all right? We'll have this being equal to 0. So basically our final answer will be 4x squared minus 9. And our answer is actually proving to be true, all right? Based on the rule of difference of squares as the third quadratic identity. So as I close off, I'm going to name all the quadratic identities right here. So the first quadratic identity, we said that it will be a plus b. Whenever you have the squared, basically means that you have this a squared here, plus, all right, the product of these two, that is a times b, giving us ab times 2. So that will be 2ab plus b squared. And the second quadratic identity, we said, will be a minus b squared, all right? So this is the what? The square of differences, okay? The square of differences. So basically, this is going to be a squared, all right, minus 2ab, a squared minus 2ab. Notice the 2ab is the same for the sum and the difference, except that in the sum we have it as positive, and in the difference we have it as negative, all right? Plus b squared, all right, plus b squared. So that is the second one. And the third quadratic identity, which we have here, basically we are saying that whenever you have a plus b multiplied by a minus b, it could be the other way around, your answer will always be a squared minus b squared. So that is it for this particular class. And I want you to basically know in this class that we can express linear expressions, all right, as square roots or squares of quadratic expressions, and we do that based off these three quadratic identities. So beware, quadratic expressions actually have square roots, all right? Quadratic expressions actually have square roots. Thank you and see you in the next class.